Okay, a question has come up over a problem such as this in Alex. I think the math is easy. The issue is getting the right number of sig figs. So in this first table right here, we are given we're given the pKa, and we're asked to calculate the Ka and to get the relative strength of that particular acid. Okay, so these are not terribly hard to do. So let's do the first one. We would set that up, number A, as 10 raised to the minus 9.27. Okay, so we plug that into our calculator to get the Ka. And when we are looking at a log scale, which is what the P is, then we ignore the first, we only look at the decimals, it should say. So we're going to ignore those prefixes in front of the decimal in order to understand our sig figs. So the answer for this one would have 2 sig figs. This one would have 3 sig figs. This one would have only 1 sig fig. So when I do that particular problem, then I get 5.4 times 10 to the negative 10th. Okay, that's what I get for the Ka. I have the right number of sig figs. It should have 2. This is not a log scale, so you don't have to worry about the decimal, but when we have a P in front, a pKa, a pH, pKb, pOH, those are log scales, and so we ignore the digits before the decimal. Okay, so let's look at that second one. Second one, I would have 10 to the minus 11.437. 3 sig figs, just looking at those after the decimal because there's a P in front of that number. That's a pKa, meaning it's on a log scale, and so this number, the correct answer should be 3.66 times 10 to the minus 12. Okay, and then for the last one, that should only have 1 sig fig. That'd be 10 raised to the minus 6.9. And when I do that, I get 1 times 10 to the minus 7th. Okay, and then you can put those in the right order. You should know how to do that right now. Strongest, middle, weakest acid. Okay, now we're going the opposite direction here. And so if I look at these, then this doesn't have a P in front of us, so all these digits are significant. So the answer should have 3 sig figs. This answer should have 2 sig figs. This answer should have 1 sig fig. Okay, so let's just do that first, the first couple here. So if I want to figure out the pKa, that's going to equal minus the log of 4.55 times 10 to the negative 3rd. Okay, that's what it should equal. Now, my answer should have 3 sig figs, right? 1, 2, 3. My answer should have 3 sig figs. So when I write that on a log scale, it's going to be 2. That doesn't count as a sig fig because it's on that log scale. It's a pKa. So that's going to be 2.342. Because that is on that log scale, then I have 3 sig figs. This is the right answer. You may think it might look like it has 4 sig figs, but because it is a pKa, it's a log scale, we only worry about anything after the decimal place. This is the correct answer for A. For B, it's going to equal minus the log of 6.9 times 10 to the negative 12th. And so when I put that into my calculator, I get 11.16. That has 2 sig figs because it's after the decimal. Remember, that's a pKa. And I get that 2 sig figs because the Ka had 2 sig figs in it. And then the last one will have 1 sig fig associated with it. So that's going to be minus the log of 6 times 10 to the negative 6. And when I do that, I get the answer is 5.2 because that's a pKa. It's on a log scale. This has 1 sig fig in it. That 5 doesn't count. So these are my answers for those with the right number of Sig Figs, and then you should easily get the strength of the acid: strongest, middle, weakest. Alright, those are way doable. It's just kind of understanding the Sig Fig rules.